Hello, this is Mr. Huber. In this lesson, we're going to look at probability and the likelihood of something to occur. That's the probability that it will happen. Okay, so to figure out probability, and you're going to see two things, theoretical and experimental probability. They're very similar, but here experimental probability means that we've actually done some kind of an experiment where we have some actual numbers to work with. We're not talking about what might happen. That's theoretical. So we'll get to that in a little bit. Experimental probability, or really any probability, is favorable outcomes over total outcomes. Okay? How many times something will happen out of how many total times your events are occurring. Another term to be familiar with, sample space. Sample space is the set of all the possible outcomes. So a little bit similar to your total outcomes, right? You're trying to figure out the favorable outcomes out of the whole sample space. So in this first example, it says there are 150 cars in the student parking lot today. 42 of them are Jeeps. What's the experimental probability? So we have an actual experiment. We have cars in the parking lot and 42 of them are Jeeps. What's the probability that a vehicle in the lot is a Jeep? So you just randomly pick a vehicle. What's the probability that it's a Jeep? So we're going to take our favorable outcomes. That's the number of Jeeps. Jeeps are, in this case, our favorable outcomes. Out of our sample space, our total outcomes are 150 total cars. Okay? So we could reduce that to 7 out of 25. So there's a 7 out of 25 chance that we would have a Jeep in the parking lot. 7 out of every 25 cars is a Jeep. As a percentage, we could turn this to a decimal. It'd be 0.28, and that comes out to 28%. So it'd be a 28% chance that we would have a Jeep if we picked one out of the parking lot. Okay, so different ways we can recognize and write probabilities. Okay, but it's favorable outcomes out of total, and know what that looks like as a fraction and as a percentage. Now we're going to see theoretical probability. Okay? This is where we're not actually performing an experiment. We're talking about how equally likely outcomes there are for something to happen. So if we have equally likely outcomes, like we're going to see down here rolling a numbered cube, a die. If you roll that, there's equally likely that you could get any of the numbers on that. Okay? So when that is the situation, okay, N is our equally likely outcomes. That's our total, if you will. Okay? And the event we're looking for will occur M times. That's our kind of our favorable outcomes, M times. So the probability of this event A happening is the number of times it would happen over the total number of outcomes that there are possible. Okay? And that's where these all have to be equally likely to occur. That's called theoretical probability. So if we rolled a number cube, not we did roll a cube, that would be an experiment. This is if you rolled a standard number cube, okay, theoretically. What's the theoretical probability of you getting a 2? The probability of rolling a 2. Okay? So understand how it's written when we write probability. So a probability of rolling a 2. So our probability of rolling a 2, there is one favorable outcome. There's one number 2 on that number cube. How many total equally likely outcomes are there? There's 6. There's 6 possible numbers we could roll. One of them is a 2. So we'd have a 1 in 6 chance, which is about 16.7%, right? Depending if we're writing as a percent or a fraction. A lot of times we can just write probability as a 1 out of 6 chance. Okay. The second one here, part B, says probability of an odd number. All right, so probability that we would roll an odd number. Not we did, we would. That's theoretical. We're saying what we expect should happen. Okay? Probability of rolling an odd number. So in this case, we still have 6 possible outcomes. There's 6 numbers we could roll that are all equally likely to occur. And there are odd numbers. There's a 1, a 3, or a 5 we could roll. There are 3 odd numbers. So we have a 3 out of 6 chance, a 1 out of 2 chance, which is 50%. Okay? There's a 1 out of 2 chance that we would roll an odd number. So again, theoretical probability, equally likely outcomes. How likely is a certain event to occur depending on what we're looking for? Probability of rolling a 2, probability of rolling an odd number, probability of rolling a number less than 5. We could figure out lots of different probabilities. Favorable outcomes over total. take a little break for some trivia. The only country whose flag is not a quadrilateral. So quadrilateral, 4 sides. We're familiar with most flags, right? We've got a flag here, maybe the U.S. flag. We've got our red and white stripes, right? Our stars. So we have this blue area here with our, our stars in it, and our red and white stripes, whatnot. So, right? A rectangle, quadrilateral. There's only one country whose flag is not a quadrilateral. It looks like this. Not a quadrilateral, an interesting looking national flag, and it's actually the flag of Nepal, which is a country in southern Asia. It's bordered kind of in between China and India. Landlocked means not having any coastline. It's not on the water at all. So it's bordered in between China and India, Nepal. So interesting little fact about that. All right, let's see some more probabilities here. A box contains 15 baseballs, 6 basketballs, and 12 hockey pucks. Okay? So part A asks us probability, right? This P probability of getting a ball. A probability of picking a ball if we grab something out of that box. So this could be any ball, a baseball or a basketball. So any of those are favorable outcomes. So there are, in this case, 21 favorable outcomes out of a total of 33 equally likely outcomes. It's equally likely you'd pick a basketball, baseball, or a hockey puck. That can be reduced to 7 out of 11, okay? Which as a percentage is about 63.6%, okay? And as a fraction reduced, 7 out of 11. There's a 7 out of 11 chance they would pick a ball out of that box. Okay? Per piece is probably picking not a basketball. So not a basketball, that could be the baseballs or the hockey pucks. The baseballs or the hockey pucks are not basketballs, so that's 27 out of still a total of 33 equally likely items and outcomes. That can be reduced to 9 over 11, which is about 81.8%. Okay, so there's a 9 in 11 chance we would pick something that's not a basketball out of that box. A couple other examples here, and you should probably be trying these on your own, right? Pause the video here, maybe try these and see if you're doing them right. So this last one here says a jar contains 22 yellow marbles, 30 blue marbles, 18 white marbles, and 25 black marbles. The first thing we might want to do is find our sample space. So our sample space would be the total marbles we'd have here. Right? So our sample space, if we add all those together, is 95. There are 95 marbles. Okay? So for part A is the probability of picking a blue or a yellow. So blue or yellow, that's 22 yellow, 30 blue. We add those together, we get 52 out of the 95. And that can't be reduced at all. We'd have a 52 out of 95 chance of picking a blue or a yellow marble. If we were writing it as a percentage, it'd be about 54.7%. Okay, so a 52 out of 95 chance of picking a blue or yellow marble. B says probability of picking not yellow. So if there's 95 total and 22 are yellow, then that means we add up the other 3, or we do 95 minus 22. Either way, we get 73 marbles that are not yellow. Those are our favorable outcomes, the 73 that are not yellow, out of still a total of 95 total marbles. Okay, so we'd have a 73 out of 95 chance, which as a percentage is about 76.8%. Okay. So again, favorable outcomes out of total. Again, this is a theoretical probability. So we're saying what would happen. Okay. Experimental is we actually did something or we have some data that we're actually looking at, like Jeeps in the parking lot. Okay. So not real different in how we calculate them. Just know the difference in the terminology between theoretical probability, experimental probability. And the main thing is know how to calculate a probability of finding your favorable outcomes out of your total. Your sample space is your total possible outcomes that could occur.